Serverless functions no longer suffer from 10-second cold starts when entering a virtual private cloud because the network interface is now pre-attached during function creation. This architectural shift enables near-instant connectivity to your isolated backend resources without the historical latency penalty. By default, serverless functions run in a service-owned network separate from your data. To reach a private database, you must explicitly map your function to specific subnets and security groups within your own account environment. This creates a secure tunnel for sensitive traffic. Select at least 2 private subnets across different availability zones to ensure high availability. If one data center experiences an outage, your function automatically scales into the remaining zones, maintaining a persistent connection to your database cluster without manual intervention. Every concurrent execution of a function requires an available Internet Protocol address in your chosen subnets. Ensure your address space is large enough to handle peak scaling bursts. Running out of addresses will prevent your functions from starting and cause immediate application failure. The platform creates an elastic network interface for every unique combination of security group and subnet. These interfaces are shared across different function versions to optimize resource usage. Understanding this reuse is vital for monitoring network throughput and troubleshooting connectivity drops. Assign a dedicated security group to your function that permits outbound traffic only on the specific port required by your database. This follows the principle of least privilege by preventing your code from communicating with unauthorized external or internal destinations if compromised. Configure your database security group to accept incoming traffic from the security group assigned to the function, rather than a broad range of addresses. This identity-based firewalling ensures that only your trusted application code can attempt a handshake with the database engine.
Once a function is placed inside a private subnet, it loses its default ability to reach the public internet. This means calls to external application programming interfaces or software updates will fail unless you provide a specific route back to the outside world. To restore internet access for functions in private subnets, you must deploy a network address translation gateway in a public subnet. This gateway acts as a bridge that translates private requests into public traffic while keeping your internal network hidden from the internet. Update the route table of your private subnet to point all non-local traffic toward the gateway. Without this explicit instruction, your function will not know where to send packets destined for any address outside of your local virtual private cloud range. Instead of a costly gateway for every service, use virtual private cloud endpoints for internal communication. These endpoints allow your function to reach other cloud services over the private backbone, avoiding the latency and data transfer costs associated with the public internet path. Distinguish between interface and gateway endpoints. Gateway endpoints are free and use route table entries for storage services, while interface endpoints use elastic network interfaces and incur a small hourly charge for high-speed access to other platform services and applications. Serverless functions scale horizontally and can quickly overwhelm a database with thousands of simultaneous connections. Each execution creates its own link, which remains idle for several seconds after the code finishes, causing the database to hit its maximum connection limit and reject new requests. A database proxy sits between your functions and your cluster to manage a pool of established connections. Instead of each function opening a new socket, they share a pool of existing links, significantly reducing the overhead on the database CPU and memory resources.
The proxy automatically handles the setup and teardown of connections based on demand. It can also manage failover events by instantly rerouting your application traffic to a standby database instance without requiring you to change any connection strings in your deployment code. Be aware of session pinning, which occurs when the proxy cannot safely share a connection between different functions. This typically happens when using temporary tables or setting specific session variables that force the proxy to lock a single database link to a single function execution. Never hard-code database credentials in your function environment variables. Use a dedicated secret manager to store usernames and passwords. Your function retrieves these values at runtime, ensuring that sensitive data is encrypted at rest and never exposed in your source code repository. Enable automated rotation for your database secrets. The secret manager can automatically change the password in the database and update its own records simultaneously. Because your function fetches the latest value on every cold start, it never loses access during a password change. For maximum security, use identity and access management for database authentication. This method eliminates the need for passwords entirely. The function uses its execution role to request a temporary token that the database validates directly, ensuring a high level of security without credential management. To use identity-based login, your database driver must generate a signature using the current regional credentials. This token is valid for 15 minutes. Ensure your code handles token refresh logic if your function remains active longer than the duration of the initial signature.
Always enable transport layer security for database connections. When traffic travels between your function and the database over the virtual network, encryption prevents unauthorized interception. Most database proxies and identity authentication methods require valid certificates to establish a secure handshake between endpoints. When connections fail, use virtual private cloud flow logs to capture information about the protocol and destination of every packet. These logs tell you whether a packet was rejected by a security group or a network access control list, helping you pinpoint the exact configuration error. A reject status in your logs usually indicates a missing ingress rule on the database side or a missing egress rule on the function side. If no log entry appears at all, ensure that the function is actually successfully launching into the correct subnet for monitoring. Your function execution role must have permission to create and delete elastic network interfaces within your account. Without these basic network permissions, the platform cannot bridge your code into the virtual private cloud, and your function will fail to execute with a permissions error. If your database and serverless functions live in different accounts, you must use network peering or a transit gateway. This requires careful coordination of non-overlapping address ranges to ensure that packets can be routed across the account boundaries without collision or ambiguity. Transit gateways act as a central hub connecting multiple networks and accounts. They simplify the management of complex environments by eliminating the need for a mesh of individual peering connections. This is the preferred method for large-scale enterprise serverless deployments involving many backend systems.
Ensure your network is configured to support private domain name system resolution. This allows your function to use friendly host names for the database instead of static Internet Protocol addresses. Private host names automatically resolve to the correct internal address within your isolated network environment. Split horizon domain name systems allow you to use the same host name for both public and private traffic. When called from within the virtual private cloud, the name resolves to a private address. This provides a consistent developer experience across different environments without changing configuration files. Align your function timeout with your database connection timeout. If your function stops before the database finishes its query, you leave orphan sessions behind. Conversely, if your database waits too long, it blocks resources that other functions could use during high traffic periods. Implement aggressive idle connection cleanup on the database side or through a proxy. Serverless scaling patterns often leave thousands of dead connections as functions finish their work. Automatically reaping these sessions ensures that capacity is always available for the next burst of incoming traffic. Design your application to gracefully handle the too many connections error. Use a retry mechanism with jitter to prevent a thundering herd problem, where many functions try to reconnect at the exact same millisecond after a transient failure, further overloading the already stressed database engine. Use provisioned concurrency to keep your network interfaces warm and ready. This feature ensures a specified number of execution environments are always initialized with pre-attached network interfaces. This is critical for latency-sensitive applications that cannot afford even a millisecond of network setup time.
Package your database drivers and network libraries in a separate layer to keep your main function code small. Smaller packages mean faster initialization times, which reduces the window where the network interface is being prepared, but the code is not yet executing your business logic. Increasing the memory allocation for your function also increases its available network bandwidth. If you experience slow database data transfers or high latency for large payloads, try increasing the memory setting. This provides a more powerful virtual CPU and a wider network pipe for data. Adopt Internet Protocol version 6 for your network to bypass the limitations of address exhaustion. Modern serverless environments support dual-stack subnet, allowing your functions to communicate using a massive address space that eliminates the complex math of managing small subnet ranges and private address pools. For version 6 networks, use an egress-only Internet gateway. This allows your serverless functions to initiate outbound connections to the Internet for updates or external data, but prevents any entity on the public Internet from initiating a connection back into your private resources. Instead of hard-coding address ranges in your firewalls, reference the security group identifier of the function directly in the database ingress rules. This creates a dynamic link that remains valid even if the underlying subnets or addresses change during a network migration or scaling event. Monitor your network throughput and packet drops using standard platform metrics. Sudden spikes in traffic can saturate the elastic network interface, leading to increased latency. Identifying these bursts early allows you to adjust your connection pooling or scale your database cluster before performance degrades for users.
Use distributed tracing to measure the exact time spent in the network segment of a request. Tracing shows you if the delay is happening in the application code, the network transition, or within the database engine itself, enabling you to focus your optimization efforts where they matter. Optimize your database schema and indexing to ensure queries finish quickly. Fast queries free up network connections faster, reducing the overall pressure on the network interface and proxy. A well-tuned database is the best way to ensure your serverless networking architecture remains stable under load. The landscape of serverless networking is constantly evolving, with improvements in interface attachment speed and security features. Stay updated on new service features and regional availability to ensure your architecture leverages the most efficient and secure methods for connecting code to data in the cloud. The ideal serverless to database connection uses high-availability subnets, a database proxy for connection pooling, and identity-based authentication. This combination provides the best balance of speed, security, and reliability for modern applications operating at any scale in the cloud environment today. Implement circuit breaker patterns to stop sending requests to a struggling database. By detecting high failure rates early, your application can fail fast and return a cached response, preventing a total system collapse caused by network congestion and resource exhaustion during a major outage. Before going live, verify your subnet capacity, security group ingress, and secret rotation settings. Test your failover logic by simulating a database outage to ensure your proxy and application respond as expected. A resilient network setup is the foundation of any production-grade serverless system.